Hey guys, welcome to RC Video Reviews. We have an interesting video tonight. I received this FRM303 from FlySky. Sorry, I'm adjusting my volume a little bit on the mic. There we go. I think that sounds a little better. So I received this FRM303. It's a brand new release. They just released it, and it is an external module. So we'll just cut right to the chase right away, and I'll give you a look at the module so you understand what we're talking about here. That's it, the FRM303. It's not unlike some of the other modules we use to enhance our RF tech on the radios. So the FRM303, 2.4 gigahertz. We're going to go over all the specs. We're going to talk about what it does. We're going to talk about the situation with hardware. I'm going to show it on the FlySky PL18, and we're going to talk about what is available with EdgeTX based radios as well. So we have a lot of material to cover. And before I get into it, I really want to say that initially it may feel a little bit like a hot mess. Okay. But if you bear with me and stick with me for the video, you're going to see the light at the end of the tunnel the way I just did when I started really doing my homework and understanding what's going on here and what they're doing with this arrangement. So I can only say, trust me, if you hang out and stick with me for this, the light's going to go on and you're going to say, oh, I see what they did there. And it's a good story. It's a good story for consumers at the end of the day. So the first thing I'm going to do is I'm going to bring up our blackboard and we're going to talk a little bit about specs. I just want to cover some specs and give you an idea of the product so you understand, what the deal is with this thing. So first things first, it is AFH DS3, which is a FlySky protocol. That is a new one. The over-the-air protocol is AFH DS3, and it is not backward compatible. So if you have a bunch of AFH DS2A receivers, for example, like the IA6B, that's a 2A receiver, not backward compatible with that. So keep that in mind as we progress. One of the big ones on this one that I'd love to point out, and we're going to talk in a little bit of detail, is this next bullet where we talk about the idea of it being a iBus capable, iBus 2 capable, SBus, and PPM. The iBus 2 thing, we're going to talk about that because every time I hear about a new serial stream, I just wonder, what the heck? Why do we have another serial stream? But we're going to talk about why, and we'll cover it. It uses the XX1280 chip, which is the same chip that we find in Express LRS. So the same chip that we find in Express LRS, that's what they used in this module, which means it supports LoRa. There is a LoRa modulation option, which provides 12 channels, plus there are 10 channel and 18 channel options as well. So a lot of options here in terms of the tech and the protocols. So bottom line, you can do PWM, you can do SBus, you can do iBus and iBus 2, all of the above, okay? That's critical because the receivers that you're going to be using with this receiver are able to support all of these different protocol streams, and they're all configurable coolly from the radio, which is kind of neat. It does support 12-bit resolution, OTA, and I also added that down at the bottom, 4096, which is 12-bit. I should have put those together, but the thing I want to say about 12-bit is I'm not going to get into a whole dialogue tonight about it because I've covered resolution in the past. But what I will say about these high resolutions is that I think that you have to make your own choices. I know it works for me, and I don't think I need anything above 10. And to me, 11-bit would just be gravy. If you're at 12-bit, if you think you can take advantage of it, fine. But personally, for me, I don't see an advantage. But it's there; it supports it. So if anything, it's not a point of contention because it's there; it's supported. It goes up to 2 watts of power. It has a closed source UART protocol, and I'll talk a little bit about that in the configuration in just a little bit, but it's got a closed source UART baud rate of 1.5 megabits. That is on the PL18. That's supported by default, so you don't have to do anything to the PL18. It just works. On the open source protocol, on the open source firmware like EdgeTX, there is protocol support at 1.5 megs as well for radios like the EL18 and TX16S, and I'll show you how that gets configured as well. It'll support up to 18 channels, although their own literature says basically unlimited number of channels, but there are practical limits, right? And the more channels you add, the more latency, the less bandwidth, all of that stuff. So there's some physics involved with it, but they say 18 is in the literature. And then again, 4096, we covered that. Additionally, it supports input power of XT30 on the bottom, so you can go up to 28 volts of XT30 power if you want to provide a little bit of extra juice, up to 2 watts. The signal interface is basically the built-in based on the module bay or the bay that you're using on your radio. That's between 5 and 10 volts. And then, of course, you can power it via a USB port as well, which will give 4.5 to 5.5. And that's for things like flashing, if you're going to flash the transmitter. So those are the high-level specs of the FRM303. Now we're going to talk about serial streams. Now, I told you, this is the part where you have to kind of stick with me. If you stick with me, I'll try and make it make sense. And by the way, the reason I did a live stream was because I wanted you guys to have the opportunity to ask questions. So that's why I did this one in a live stream. But let's cover what I know. And before I get into any more material, I do want to give a shout out to my boy, Richard. Richard's one of the developers that is helping bring FlySky protocols into EdgeTX. He works on the EdgeTX project, and he's exceptionally knowledgeable on this stuff. So a lot of the technical material I got from Richard, and I sanitized it via Richard and my contacts at FlySky. So I just want to give a shout out to Richard and say thank you, my man, for helping me get my arms around this so we can explain it to people the best way we can. Okay, so a little word on serial streams. I told you when I first saw that this was iBus 2, I said, why do we need another serial protocol? I don't understand. And I know people get frustrated with this because you have to keep up with, well, CRSF, SBus, iBus 2. What is the deal, right? So here's the deal with iBus 2. I put it right at the top. You can see 1.5 megabits comes out of the serial stream. So 1.5 megabit data rate on iBus 2, which is substantial. It is very impressive, very fast. And as you compare it to the older protocol, iBus, they're at 115.2K. SBus is only 100K. And then CRSF, which we all know and love, is 416K. So if you look at it, this is why I left the thumbnail and said, did FlySky just do a mic drop? Because they're delivering a protocol that supports a 1.5 megabit data rate, and it enables telemetry bidirectional, so two-way, and it allows for parameter settings. So all really good stuff. As the sensor space kind of gets crowded out there and you have options for sensors, the iBus 2 protocol really allows you to use some fairly complex sensors on a single bus and not have jam ups in terms of delivering data. And that what that means for you in an operational sense is you get a lot of bandwidth to use for control because things happen so fast, right? The data that you're going to transmit happens really quick, so it doesn't clog up the line with information. And in addition to that, if you go look, and I did put a link in the description of the video for the FlySky specification and a little bit of an FAQ, they talk about this concept of having two radios for transmission of data. So the bottom line is they really made a mass improvement over the rest of the market in terms of data rate. And here, the next section down, we talk about the maximum data volume in a single transmission. iBus 2 goes all the way up to 64 bits. VBAR, which is pretty popular in the heli space, goes up to 12 bits. FPort, which I think most of you are familiar with, is up to 4 bits. So you can see that there's a massive improvement in the amount of data that can be transmitted in a single transmission for telemetry. And for large sensors such as GPS, iBus transmits the data in one single packet. So that is kind of a cool little feature of this serial stream, and why iBus 2, now you can sit back and say, oh, well, now I think I kind of understand why they introduced iBus 2, right? Why does this make sense? It's because if you look at it compared to the others, minimally, they tripled the speed of the data rate for telemetry and parameter settings. So I think that's very cool. Okay, now we'll talk about supported radios. This one is one of those deals, again, I think as I start talking about it, your eyes might glaze over a little bit, so feel free to ask questions if you have them. I'll do my best to explain it. And then what I really want to do is get into the summary, which will be after the software. So there's a summary slide that'll boil all of this down into a nice, simple, consumable nugget. So just please stay with me for that part. Okay. FlySky, so supported radios. Right now, we've got the FlySky PL18 with the FlySky firmware, and I'm going to switch over to my desk. This radio is fully supported right now. It does AFH DS3, which is the over-the-air protocol, and it does iBus 2. It's all supported right now. You plug that module in and you get all of the features of the FRM303. So in the FlySky platform, you're 100% ready to go. And that makes sense to me. This is their platform. Why wouldn't they do that, right? It makes sense that they set their own radio up first, and it does work beautifully with the PL18. I'll show you the setup on this in just a minute so you can get a look at the tech, but it works out of the box with the PL18 with no touches at all, okay? That's important to understand. Now, the other radios, the FlySky EL18, which is the NV14 successor, that works with Edge TX 2.8.3, which includes AFH DS3 as an over-the-air protocol and iBus, but not iBus 2. iBus 2 is not yet available in Edge TX. So if you're flying either the EL18 or the NV14, you will not get iBus 2. You'll get iBus, but you will get AFH DS3. I hope that makes sense. Next up is the TX16S. I'm going to talk about the hardware mod in just a little bit, but there's a hardware mod in order to have the FRM303 support bi-directional communication, meaning over the air and telemetry. So you have to have data moving in both directions. You need to conduct a hardware modification if you want to use it right now. Hang tight though, hang tight. So you also will need a 2.9.x nightly. I can confirm that the nightly from last night, it is May 25th, 2023. The nightly that I flashed on Precious was from May 24th, 2023. And with that nightly, AFH DS3 and iBus are supported. So it is in Edge today, and it will bind with the appropriate receivers today. Okay, but keep in mind, that's a nightly, it's not production, okay? Non-FlySky radios. So this is where we talk about production. What's in production today? In production, non-FlySky radios like the TX16S without a hardware mod can use PPM or S-Bus to communicate with the FRM303, but that means you won't get telemetry, okay? You won't get the bidirectional. You'll only get the over-the-air control. That's it. No telemetry, no parameter settings, okay? That's where we are today. If you go out and buy it, put it in your TX16S, you can enable it via PPM or S-Bus, and you will be able to use the over-the-air protocol, okay? And by the way, you'll need a nightly. Just keep that in mind, you need a nightly, because remember, 2.8.3 supports AFH DS3 on the FlySky radios only, okay? Okay, so that's it on the radios. I'm watching the comments. I don't see any questions about the radios. I must have done a really good job, which means Richard did a really good job, because all of this was fleshed out with Richard directly. So Richard, again, thank you, man. I appreciate you. Thanks for the education. Okay, now let's talk about Edge TX. Okay, here's the deal on Edge TX support. Edge TX 2.8.3 on an EL18 or an NV14, they give you AFH DS3 and iBus today. Not iBus 2, but iBus today. There is no support for non-FlySky radios in Edge TX 2.8.3. Because I only did this because I know in the comments I will get 100 comments that say, I'm running 2.8.2. Can I run? No. There's no support for AFH DS3 in 2.8.x. You have to be on a 2.9.x nightly if you want AFH DS3 in a non-FlySky radio. For Edge TX 2.9, that provides AFH DS3, but requires the FRM303 firmware update in order for bidirectional. And on that note, I have talked to FlySky. They have said we intend to produce a firmware update on the 303. So in order to get bidirectional communications working on the FRM303 and a radio like a TX16S using Edge TX 2.9, you will need to get a firmware update from FlySky, or you can do a hardware mod, one or the other. So if you don't want to wait for the firmware update from FlySky, you can feel free to do the modification. It's not that hard. I'll show you a picture of it, and you'll work, or you can just wait for the firmware update, okay? And then finally, Edge TX 2.10.x has planned support for iBus 2. So that's when we think we will see iBus 2. That's the general plan right now, is 2.10.x. Okay, that's when we expect to see planned support for iBus 2. All right, I know I'm coming at you guys pretty hard, but I promise you this is it. Here's what you need to know. Status as of late May. This is the summary. I told you I'd boil all this down into what you need to know. So here's the summary. Status as of late May 2023. Your FlySky PL18, all features ready and available now. Full stop. Ready to go. If you have a FlySky EL18 or NV14 and Edge TX 2.8.3, you get AFH DS3 and iBus, no iBus 2. If you have a TX16S with no modification, you can use Edge TX 2.9 nightly as of today that has AFHDS3, you'll need to use PPM or SBus, and you won't get telemetry. And then if you have a TX16S with the hardware mod, you can use EdgeTX 2.9 with the nightly. That has AFHDS3 and iBus now, no iBus 2. On the roadmap, EdgeTX 2.9 adds AFHDS3 and iBus. 2.10 adds iBus 2. And then we expect a FRM303 firmware update from FlySky to avoid the hardware mod. That's the summary. So I'm checking for questions. I'm not seeing anything, so I'm just going to keep motoring along. And let's take a look at the hardware. So what I want to do next, again, I'll keep watching the comments. If you guys have them, we'll get in. I'll do what I can to answer them. I already gave you a look at the module itself. There's the module, and it's just like any other module. It plugs into a bay in the back. I'm going to turn the radio off, and then I'm going to pull the module out. It's going to complain about the receiver being connected, so that's fine. So I'm going to pull this out and give you guys a look. Now, I do have to tell you something. There's two different kits for this guy. One is what they call, the junior model, and that one doesn't have that one has a standard dipole antenna and a few less connectors in the box. This one is called the Carefree model. That's the Carefree product range, and it basically is the full Monty. It has everything, including a Yagi antenna that I will show you momentarily. But in the meanwhile, because I didn't want a great big Yagi sticking out of my transmitter for testing, I used an Express LRS antenna from Radio Master. So that is a 2.4 gigahertz Radio Master antenna on there, and it seems to work. There is a button for configuration. There's an LED that lets you know what's going on the module. And then in the kit, they give you these little adapters. This particular adapter screws in right there, and that allows this adapter to fit cleanly in the PL18. So you can pop out the FRM301 that comes in the PL18, and you can replace it with the FRM303. Okay, so that's how I have this one set up. We're going to look at this radio first, but other than, the module itself, I'd like to show you what else is in the kit. So let me get the lid off. And here's what you get in the box. We're going to take a look at the instructions. There's English and Chinese. We're not going to read all of this, but one thing I do want to point out to you guys really quickly is the input mode. And there it is. I found it. Input mode. This one is critical, and I will show you this on the TX16S, but you're looking for this section right here called the input signal settings. Now, if you're using a PL18, you need to put it on the closed source protocol. If you're using a TX16S and EdgeTX, you need, or an EL18, you need to use the open source protocol. That took me a little while to figure that out, but once I figured that out, it popped right up and worked, okay? So instructions are fairly thorough. If I need glasses, I can't read fine print that small, but the instructions are pretty decent. They kind of show you what all the different connectors are for, what the different wiring types are for, how the different modules plug into the bay. It's all here, so I'm not gonna bother reading this kind of stuff to you guys. It's in the book, okay? So depending on your use case, you've got a whole bunch of different connectors that you can use to get this working with your radio. Okay, so that's the manual, little color brochure. This is the FRM301 module that came stock in the PL18. So that's what that looks like. I'm not using that now. I've got the FRM303 in there. And then in the box, let me zoom in a little bit and we'll cover some of the goodies you get in the box. Okay, inside the box, plenty of screws for the different mounting implements that you might need depending on the radio. So these are intended to screw different brackets and braces on depending on which radio you're affixing it to. This bracket actually came off the PL18. That's what holds that FRM301 in there. So in addition to the brackets I mentioned, you get all these different connection and signal leads for different use cases. So this one is a DIY. This one is a 3-pin servo connector. This one is a 3.5 mil audio jack, so maybe like a trainer port style connection. And then they also have this is the Futaba style, so that's the Futaba style connector. And then finally, there is a DIN, 5-pin, I think 4-pin DIN connector if you have a radio jack on the back that requires that type of connection. So lots of different wiring options to get the module connected to the radio that you might be using it in, okay? I thought that was very thorough, to be honest with you. They give you a couple of Allen screws to assemble the things you need to assemble. And then here's the thing that I really wanted to get into, we have two things I need to get into. One is the antenna. So here's what I was talking about. It's kind of like, I think it's a Yagi. If you're an antenna expert and you know whether or not that's a Yagi, let me know in the comments, but I'm pretty sure that's a Yagi style. So very directional and very, very, very long range. This is a very long range antenna. That's another reason I kind of use just a standard T antenna. Was I personally don't intend on doing this, but remember, you get 2 watts of LoRa. So I've heard testing is indicated upwards of 80 kilometers range with this guy. I haven't tested that myself, so I'm not telling you that firsthand. I'm just heard, rumor, but I've heard up to 80 kilometers with this antenna and 2 watts on that device. They give you a little XT60 to XT30 adapter. So if you want to plug a battery in on the bottom, you can do that. This is a connector for a radio like the I always mix them up. It's the EL18. This is the red one, the Elysium 18. So if you want to mount the module on an EL18, that's the panel you would use for that one. And then in addition to that, I told you about the one for the PL18, that's right there. And then you also get an adapter that works on a standard JR bay. This came in the box as well. This is just a standard, if I can get it to pop out here. That's just the standard adapter, and you can see the signal pin goes into the bottom of the module. So the kit, all I can say is the box is very thorough in terms of the hardware that you need to get this up and running depending on your radio choice. So a lot of options with hardware. I give them a lot of props for that. I think the one thing I would ding them on the Carefree case is I don't really want this big old Yagi sticking out of the top of my radio when I'm at the field. It's just cumbersome. I get it for long range. It makes perfect sense. I got that. But for day-to-day line of sight flying at the field, I'd rather see something like this. Dipole, T antenna, whatever. I think that's the one gap that I would see in the hardware. They need to just include a standard antenna that, we can put on for radios when we're at the field, having a normal fly day. Okay, that's the hardware. That's a look at what you get in the box. Now I want to put this stuff to the side, and we want to pop this radio in the PL18, and I want to show you how it goes. So I'm just going to plug it into the bottom here. It's nothing to see there. Nothing to see there. Keep moving. Nothing to see. I'll turn the radio on, and then over here on the side next to my connected to my handy dandy power supply. Let's see, it wants all my switches in the farthest position, right? J3. I don't know which one is J3. We'll just hit go. Okay, and I'm going to zoom out just a little bit. No, you know what? Before I zoom out, let me show you what's going on the configuration on the PL18 first. So PL18, what we're going to do is hit basic, and then we're going to hit RX setting. And this is one of the really cool features that I think you're going to see if you want to set parameters or change your protocol settings in EdgeTX. So you can go into bind settings, and under bind settings, I had to get my pencil. Don't judge me. I needed my marking. I don't know why. I don't know why. I need to remember to put this pencil in front of me. Okay, so here are the different protocols you can use on the PL18, but not all of them are available on the FRM303. What I can tell you is that LoRa is available, Fast Channel 8 is available, and CFast 10 is available. I haven't tested Classic yet, and I haven't tested Routine, although I think Routine is also available on this one. So that's why you get up to 18 channels. Remember, we talked about that? Now, as far as the bind process goes, here's what I want to do. I'm going to switch it to LoRa, and it's going to complain when I switch to LoRa. It's going to say, hey, for your safety, turn off the receiver first. Okay, I'll do that. And let me bring the receiver into view so you can see it. The other thing I really like about these receivers, these new receivers these enhanced receivers that are supporting AFH DS3, is that you don't have to do anything to bind them. So I've turned the receiver off. I'm going to hit exit. Now I'm going to hit bind again. And it says this does not support FTR10. So it tells you which receivers it doesn't support. Remember, this is LoRa technology. So you have to have a receiver that supports that as well. So I'll say got it. And now all I'm going to do is bring power on to the receiver. You see the bind light right there, blink, 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 and solid on. There we go, we're bound that fast. How cool is that? I mean, I think that's pretty cool. And here we go, there's me moving let me get the stick in here so you can see it there. Moving the stick, and we've got full movement. I just changed from I had it on fast. I had it on fast 10 channel, and I just changed it to LoRa. I think I changed it to LoRa. It says, please turn it off. Maybe I didn't do LoRa. Did I miss the button? It's off. Come on. Let's try it again.
Signal lost.
Says I have to rebind. Okay. Maybe I missed that. All right. Got it. We'll hit got it. Sorry. I missed it. but it'll do the same thing. So there's the light, and we get a quick flash and a bind. So it's the same deal. And there we go. We have movement. So same deal. That's how fast you can change the protocol choice. Okay. So very good. I like that a lot. Very simple to use depending on your use case. You also can set the custom port protocol. On FlySky, they use these MPA and MPB pins, and all that is one set of pins. So right here on this MPA, I've got a altimeter sensor, and you can see that that's got the red solid light. This is iBus 2, and I've got that enabled. And the way you do that on the FlySky is you go into your, it's the custom port protocol, and then you select the pins you want to use, and then select the protocol you'd like to output. So this is where you can change from SBus to iBus 2 to iBus out to PPM, whatever you want. You can also do PWM. So if you want to use that MPA channel for PWM, you can do that as well. So you get all of these options. I love this because of the flexibility, right? You guys have heard me say it all the time. How many of you have watched a video of mine where I'm looking for some kind of converter, some kind of converter board, some kind of SBus board? This does away with all that because I can choose PWM, PPM, which I don't ever use, SBus, and iBus in or out, and iBus 2. And it's all configurable right here, and it's real time. So very cool. And if I were to set that to SBus out, that means this MPA pin right here would be an SBus protocol out signal. Very cool, right? I love it. I love this kind of technology. That's why I said in the thing, that's why I said in the thumbnail, did they just mic drop? Because that's pretty freaking cool. Okay, now let's take a quick look at telemetry. There's one real cool thing in here I want to show you. There's the standard characters on telemetry, right? You got RX voltage, signal, RSSI, all the standard stuff, but look at that one. BVD voltage, that is battery voltage detect. That's what that stands for. And that is a single wire. It's right here. This is my BVD, and all I've done is connected my BVD to my hot lead coming from my power supply. It's right there. So that's my BVD wire. One wire going into the receiver. It's one white wire going into this pad right here on the receiver, and you've got battery voltage up to 100 volts. I love that. I am right now, all of my planes, any plane that I build from this day forward will get battery voltage one way or another. And so I really like that they did BVD and made it that simple, incorporated it right on the receiver. Now, just to give you a look, I'm going to bring the voltage up on my power supply, just 1 volt. So there we go. We should see a hit. There we go. Ran up to 6 volts. I'll bring it up one more. I don't want to do too high because I've got these little cheap servos. There's 7 volts and then back down to 5 volts. Okay. So there's your battery volts. Actually, I hit 4 volts. So there's your battery voltage detect. And then the other thing you'll notice on here is the height. It says 144 feet. That's the little altimeter. All you have to do is plug it in. That's all I had to do. If I unplug this, we'll get a sensor lost. I'll take the altimeter off, and that sensor goes away. So remember BVD, it was right below there. It's gone now. And if I plug it back in, it just picks it up on its own again. So I think I got to make sure signal is on the outside, right? So you plug it in, you get the solid red light, and right away the radio picks up the height PR and puts the altimeter right back in where it belongs. How cool is that? I mean, you know, I don't know what to tell you guys, man, but I think that's pretty impressive stuff when you think about what I just showed you. You've got 2 watts of LoRa, which we all know has been proven at this point to have exceptional range. We've got a pretty nice selection of sensors running iBus 2 that are plug and play. The bind process is no touch. You basically just turn your radio on, put it in bind mode, turn this on, it looks for a bind, boom, it'll marry itself up to the transmitter, and you get an immediate connection with your devices using any of the output protocols you want: PPM, SBus, iBus 2, and PWM as well. Don't forget that. So that's it on the FlySky. I'm going to check comments and see if I have anything in here. And if not, I'm going to keep moving on. I love how simply made BVD. Yeah, I love BVD. BVD is really cool. For a TX15S, you need the hardware mod or wait for FlySky. Yeah, they did not give me an idea when the firmware upgrade is going to happen yet. I don't know yet. Brett asked about when the firmware update is going to happen. I've been keeping very close tabs on this, talking to not only the Edge developers, but my contacts at FlySky, and all I can say is they're working on it and they have a path forward. Okay. So Jeff asked if 2 watts is legal. Jeff, I'm not going to answer that question. That's up to you. I'm not, look, look up your own local codes and figure it out. I'm not. I refuse to get into those. I'm not the father. You know, these guys can do what they want. I'm just telling you what the hardware is capable of doing. And it's really the big mistake I think about all of that business with whether or not things are legal is less about the power output and more about the EIRP. So check into that, you know, check into what is normal when it comes to EIRP for your locality, and that will help you determine what's legal and what's not legal. Okay, so with that said, what I want to do next is I want to bring it into a TX16S. So here's Precious. And before I do, let me show you the workspace real quick. I'm going to bring up a workspace and I want to give you a look at the modification, because it's important for you to understand the modification that would be necessary in order to make this work on a TX16S in the absence of the firmware update that you need from FlySky. Okay. It's actually not that big of a deal. This is your, and this, by the way, is published on the EdgeTX GitHub. The link for this is in the description already. So if you want to go look yourself, you can. And there's some instructions by Richard, who's one of the, you know, he kind of came up with this. So the bottom line is on your multi-protocol module, your 4-in-1, you have to pull these 2 wires out and replace them with 2 wires and run those down here to a UART on the board. So in my case, I just soldered a couple pins in and I used a standard servo connector and I just dropped it in there and it worked. No problems at all. And it does not preclude any of the normal operations of your 4-in-1. So if you're willing to solder, and the holes look just like these, by the way, they're just holes in the motherboard. So if you're willing, in fact, I even have one of the pins here. Let me show you this. Here we go, overhead. This is one of the pins. I just took this off one of my standard, you know, my standard electronics gizmos out of my kit, and it's a standard header pin, right? I put 2 of those in the motherboard and I soldered them in. So if you're willing to do that kind of work, this is the modification. You have to open the radio up, use these 2 pins on the left-hand side of the CPU and bridge them into the 4-in-1. And when you do that, the radio will work with AFHDS3 on EdgeTX with 2.9 and the current nightly. Okay, now that said, there's a couple other things you have to do as well that I need to show you. So 1 second, I got to get a battery. I mentioned something about the input signal, so let me show you how that works, because if you're going to switch back and forth between FlySky and one of the open protocol options, you need to change from the UART code from closed source to open source. Okay, let me show you how to do that real quick. It's very important to understand this step because it will not work if you don't do this. So right now I just have the module, and I'm going to and keep in mind there's a couple. I didn't show you this, so at the bottom you have the ability to select internal, off, and external. I'm going to turn it to off right now, so we're just going to set it to off. And then I'm going to plug in a battery. This is just a little 3S LiPo. All right, just plugging that in. And now what I'm going to do is I'm going to push this little rocker. It's a D switch, so I'm going to push it to the up position. And then I'm going to turn this switch to external power. That will turn it on and put it into input signal mode. And mine should blink 3 times. 1, 2, that was 3. 1, 2, 3. 1, 2, 3. That is the closed protocol 1.5 megabit UART. Okay, to switch to OpenTX, you simply push it down 1 time, and now it should blink 4 times. So 1, 2, 3. Whoops. 1, 2. Oh, I went the wrong way. Let's go the other way. Did I push it down or up? I don't know. We'll find out. There's 3. I'll do it again. There's 4. Okay, so you push it up to go down in the list. So you need 4 blinks of the blue light. So 1, 2, 3, 4. There we go. That's the open source UART protocol. Okay, very important to do that when you plug it into an EdgeTX based radio. Once you've done that, all you have to do now is press down on the D-pad for a couple of seconds. You should hear a tone. I think you're supposed to hear a tone. There it is. And then you hit left and that exits the programming mode. Now we're set up for OpenTX or EdgeTX, okay? The open protocol. So I'm going to unplug that. I already have this little adapter on the back, so I'm going to cheat a little bit. And I'm just going to plug this into my adapter and we're going to lay it down on the desk. I'm not going to go through the whole unscrewing and screwing in the adapter. I don't think you guys care about that on a live stream. So all I'm going to do is take the JR adapter. I'm going to plug that into the bottom of the module. And then once I've done that, I'm going to plug my adapter back into the radio. So, okay, so this is all I've got here. I've just used the adapter bay. That's it. And now I'm going to lay this down on my desk, because everything else that we're going to do, we can do within the radio. So I'm going to turn the radio on. And there's a couple things I need to show you in terms of the configuration for Edge TX, okay? The first one is you have to click on the radio settings button, go over to the hardware tab and scroll down, and you need to look for aux 1. You see aux 1 right here? And you need to set that to external module, okay? You have to set that to external module. You do not need to turn on port power. Just set that to external module, and that's how the radio knows that on those 2 pins that we used internally that we're talking to a FlySky module. Make sense? Okay, now that we've done that, we can go back into our radio settings or our model settings. So I'll hit model, and then I have external RF, and I see FlySky. It says not ready. So, oh, that's because I have the switch on off. So I need to turn the switch on. Need the switch on. You need to see blue, not red. If you see red, something's wrong, but I see blue, so we're okay. And now we see a status screen right here that says disconnected. That's my fault. I forgot to turn the power on to internal. Okay, so now we can see, by the way, let me show you the firmware version so you guys can see it. I don't make this stuff up. This is nightly. This is a 2.9.0 nightly, all right? And I just got this thing last night. It was from yesterday, the 24th, okay? So that's the nightly I'm using, and it works. So I'll back out again, go into model settings, hit external RF, and you can see I've got an option for FlySky, AFH DS3. I'll turn the brightness down a little bit so you guys can see it, hopefully a little better. We've got options for, again, LoRa 12 channel, all the same things we saw on the PL18. We've got Classic 18, CFast 10, Routine 18, Fast 8, and LoRa 12. I love that LoRa 12. Man, LoRa, I love LoRa. I love LoRa. LoRa is awesome. And so LoRa 12 channel, and the reason I like that for this is because obviously the range, right? I feel very comfortable flying LoRa modulations on my radios. You can choose between CE and FCC. There are some module options here. I've asked for a little bit of information about these in terms of what PWM sync means, but here's the cool thing. You can set the servo rate per servo. So check that out. You can set the servo at 50 Hertz, 333 Hertz. So if I have a digital servos, and I want to run those at 333 Hertz, I can do that. And you can also click on custom and set whatever rate you want to set. This is what I mean about a mic drop, man. What freaking technology does this? Like, this is next level stuff. I do have a request in to get a definition of what the PWM sync does. I'm not sure what that does. I have a feeling it might have something to do with an internal clock or something to do with the calculations inside. Not sure yet. I have asked. So when I figure that out, I'll post it in comments. Okay, so those are the module settings for the external RF. You can set your channel range. Obviously, we're 12 channels, so I don't think we need to really bother setting this lower, but what the heck, we could. We'd set it to 12. We'll set no pulses for the failsafe. And then all we have to do is bind. Now, I'm going to show you guys the bind process again. So remember, we just had this one bound to the other radio, okay? I'm going to bind it to this one now, and I'm going to do that by hitting bind. And all I'm going to do now is apply power. That's it. I'm not doing anything to the receiver, but you see the fast blinking, and there's the solid light, and we got a connection. It says connected right there. Now let's back out, and I'm going to hit the telemetry button. I'm going to delete all these sensors. Oops, delete all. Yes, and then we'll discover new, and there are the sensors. So the sensors I'll cover really quickly. We've got our BVD. We've got our altitude. That showed up in meters, by the way, so meters for altitude. We've got temperature 1, which is the temperature of the internals on the transmitter. I'm not sure what pres is. Maybe I can get a little help from the guys. Maybe Richard or one of the developers will comment. In fact, there's -40 and there's 32. One of these two is the chip inside the transmitter. I'm guessing it's probably 32. I don't know what the -40 is. That looks to me like an error. This temp 2 might be a more realistic 32C for the transmitter chip. And they also have TXV, which is supposed to be transmitter voltage. That's showing up as 0. Maybe that has to do with external power. Not sure. And then we have the pack volt or the transmitter voltage A1 right there, 497. That should be what's coming into the receiver, A1. That should be the receiver voltage. And then we've got our standard radio information, RQLY, RSSI, and signal to noise ratio. So all the standard stuff on telemetry that you could want, and that's all running on a TX16S with the module, not in the bay. Remember, I kind of cheated a little bit. So it's not in the bay, but it would easily mount in the bay. I've had it in the bay to do all of this testing. And there you go. So there's AFH DS3 with an iBus sensor on a advanced FlySky receiver. And let's just move the stick real quick so you can see that happening. I mean, that should be obvious, right? There goes the stick. So we got a nice bind. Pretty cool. All I can say, I think, let's talk a little bit about things that I think they need to care for. And I do want to go back to the workspace too, because I have a couple of pages that I want to show you real quick before we break. So I think what they need to care for is, number one, they really need to get some US presence for receivers, because right now the only place that I can find these advanced receivers is on AliExpress. So, or on their website. So they do have an online store. You can order from them, but they're not in like race day quads. I'm hoping like race day quads, Get FPV, Heli Direct, A Main Hobbies, you know, some of the more mainstream online retailers start picking up these modules because it's a pretty cool system. I mean, I'm really kind of interested in the system quite a bit. I think it's pretty cool. So I put a link in the description for information, more information about the FRM303. So if you want to look at the specifications, you can do that. They've got a nice website that kind of explains a lot about what's going on. They also have an online store. So here are some of the RF modules. And this is kind of going to give you an indicator, like, you know, they launched it, but you can't even buy it on their site yet. So for those of you who will ask the question in comments, I don't know where to buy it yet. I know it's been launched. I got an email from my contact at FlySky saying it's officially launched in China. You can go ahead and do your video. So I'm not sure, you know, where the retail situation is going to be, but knowing what I know about FlySky and where I get certain FlySky gear these days, AliExpress probably a pretty good starting place. So keep an eye out there if you're interested. And then also, like I said, here's a picture. This description, or this link is in the description. Here's a picture of the modification you need to perform if you want to have full bidirectional. That's it. That is the content. And I'm going to bring up the summary. I'm going to leave that up so you guys can have that. And then I am going to take a look at the chat real quick, and I will go through questions, and I'll see what questions you have, and then we will end this one. So I'm going to scroll back a little bit, and let's see. That sounds just complex. I bet this is EdgeTX. Once you understand the language, is simple. It is. Yeah, it is. Once you kind of get the hang of it, it's really not that hard to understand. And what I really like about the FlySky stuff in my experience so far is it has been very, very much plug and play. So like once you get the configuration right and you get it talking to the radio, everything just works. I haven't had any problems getting things to work. Technically, almost everywhere 2 watts is not legal. Yeah, so no Robert tonight. If I buy the system, will my name come on it? No, that was a special, that's a reviewer's edition there. Sorry about that, Chris. Let's see. I have a 3-watt VTX analog for my long-range mountain surfer, but I only use 2 watts really. Nobody complain because I'm in Pacific Northwest. Standard 0.1-inch header pins. Yeah, standard pins. I just plugged them in. I did have to bend them over a little bit because if I put them in straight up and down, the case didn't fit. So I just kind of bent them a little bit and slid the servo connector on, and it's on. It's on. No problems at all. It stayed on there pretty good. This module has an actual FCC ID that actually exists. Very promising. Yes, it does. That's a good point. I thought about posting that, but I thought I had a lot of minutia already, so I waved off. But thanks for pointing that out, Daniel. You're right. It does have an FCC ID. Spin launch glides is like trying to program an ESC without the programming box. By the way, that's another thing that they talk about. Let me go back up and we'll talk about the a word on serial streams. Notice this section here on parameter settings. Keep that in mind because that's going to allow you to do things like program your ESC, like program your flight controller or program your gyro. In fact, FlySky has a request for cooperation out there where they're asking developers to participate in iBus 2 development. So they are looking to utilize the strength in this data transmission rate to do some very advanced programming from your radio to your model. So that's what the parameter settings comment is about. I'm afraid I didn't cover that in much detail initially, but that's what that one's about, is letting you set parameters on the model, being a bidirectional protocol. Okay, let's see, 250 milliwatts permitted. Okay, the module has an actual FCC. Yep, we talked about that. Who do you think is aimed at? Higher channel count PWM flyers? No, I got to be honest with you. I believe it's aimed first at their PL18 because you get some serious protocol capabilities in the fact that you get LoRa, which can do long range, you get PWM, you get S-Bus, you get iBus. So you get all the standard stuff for line of sight type flying, plus in one receiver, one transmitter module, you get the ability to go long range if you into that as well. Keep in mind, on a standard radio like the TX16S, we get away with that and we're a little bit spoiled, but part of the reason that we're a little spoiled is because we have the module on the back. And I'm just going to go ahead and disconnect this. So we have, what you have to remember is with the NPM, come on, there we go. With the NPM internal and an Express LRS or TBS Crossfire or Tracer or Ghost or whatever external, you really get a lot of extensibility out of this radio, right? It's a great deal of extensibility. On the FlySky radio, like the PL18, for example, they don't have an internal multi-module. So they rely on this bay, and in this bay, you can plug in the FRM303, and now you've extended this radio to do LoRa, PWM, S-Bus, all the above, all that stuff that we covered. So I think it's actually aimed at both line of sight. I believe it's aimed squarely at line of sight pilots, and I believe it's aimed at long range pilots because it's using the same modulation over the air as the technology that we know and love that's been well proven out at this point. And it's got an exceptional power output capability. So you can really jack the power if you want to fly long range. That's what I think it's aimed at. I think it's kind of like, and by the way, this is what I've been asking for from Express LRS, right? Express LRS, I want to see things like hopefully S-Bus 2, where we can add telemetry to the S-Bus output. And now we've got a single solution where we have PWM, S-Bus, telemetry, and CRSF. So that means we can connect to everything. We can connect to quads, we can connect to gyros, we can connect to iNav flight computers, or we can connect to servos. And that's what this device does now. That's the magic of it. This device right now, I'm going to unplug it from power, so I hope we're done looking at that. And by the way, you get some decent little sensors. I did a video on the sensors that work with this TR8. You get, they have telemetry, voltage, current, altimeter, all kinds of stuff. So depending on what you need for sensors, it's all there, right? This is a very complete setup where if you add this module, you can pretty much do anything. You can do S-Bus, you can do LoRa, you can do it all. You can do iBus. I know the A3 Super 4 gyros work great with iBus. So you can do iBus, iBus 2, it's all there, all of it. So I think that's why it's a mic drop, man. That's the point. It's like, holy smokes, man, these guys came out swinging. There's a lot of technology going on here, and it's very cool stuff. All right, Hobie says, you love my wife, rather you than me. Oh, I'm going to pass on that one. Captain Bry, you're not kidding. That's some awesome integration into Edge. Yeah, it is. Captain Brian, I know you watch this stuff too, Brian. So, all I can say is I hope it gives you guys ideas, and, it's great. The ideation is wonderful. I think the collaboration with Edge is wonderful. It's good. It gives people choices and options, and that's what's most important. So very good. Steve Barr says I have both Spectrum and FlySky, and I think I get quite a bit more range with signal with FlySky. Yeah, I'll leave that alone. I'll let the I don't need to whip out my cripple hammer on Spectrum. I do that enough. Brett says precious is pressure. That's the atmospheric pressure that then gets converted to altitude. Okay. Tell us the price in the ATA. I don't know. I don't know. Brett wants to know the price. I asked. I'm kind of hoping it comes in under $100. I put in my 2 cents. I said I kind of hope you come in around 100, maybe slightly less, but I can't answer. I mean, I think personally, if I were to put a price on this, if I saw this, everything that you just saw tonight, and I had to buy my own copy, I'd say I'd lay out $75 pretty easy, especially given the capabilities that are available in these little itty bitty receivers. And by the way, I can cover that too. I'll bring the workspace up, but I'll show you the receiver lineup. You won't believe it. They've got a truckload of receiver options for you on this one as well. Daniel says, I do like the features, but I've been burned once on the FRM302 that's now a paperweight. Yep. Sorry about that, man. But that was more, I wouldn't necessarily put that fault on FlySky. That was really, I talked to the developers about that, and that was just really a situation where, let me put it this way. FRM302, it's an old thing that's going to die. I almost got one, but I waited. The FRM303, they fully intend on supporting an EdgeTX. That's all I'm going to say. Jeff says, nitpicking, but it would have been neater if the module connected to the various adapter plates via internal pins rather than that external. Yeah, I know. That would have been cool. But, you know, I think, Jeff, for me, like once you plug it in and set it up, you're done. You don't really fiddle with it, to be honest with you. So I think it's fine. Like once this is in the radio, when I put that on there, when I put that pin on and then I stab that in the back of the PL18, that's it. In fact, on the PL18, they even have these screw holes so you can screw it into the back of the radio and they go in right there. So you have to screw it in and that way it doesn't come out. But, you know, that is a nitpick, but not to me. It's just not a big deal. It's fine. Let's see. Marcel off axis. I'm very curious for sure. The exciting thing. Okay. Jeff says the exciting thing for me is the great work being done by the Edge devs to support. Yeah, they are. And I watch their GitHub. You know, I pay attention to the GitHub. I watch it and I kind of see what they're saying and where they're going to spend the effort. And there is support for this. They do want to see this module fully supported in EdgeTX. And I know Richard has a very good working relationship with the FlySky team. So they'll work together. They'll collaborate. And that's what it's about. That's what it's about. Okay, let's see. Drummond says, how much is that model? Don't know yet, Drummond. I haven't been given retail pricing yet. I'm hoping it comes in around 75 to maybe 85 bucks. That's what I hope. Brian says, I'm also digging that layout for 8-channel real space saver. Yeah, absolutely, man. It is. And by the way, don't forget, you can also abscond with 2 of them for telemetry sensors as well. So they're configurable. You can say you've got I know my camera's not helping me here, but you've got, let's see, this one is NWA, and this one is NWB. So those are configurable for whatever output you want. You can either do S-Bus, PWM, or iBus, so you can plug sensors in to both of them if you want to. Very cool. Very cool. So you get a little 6-channel with a couple sensors you can add. Very simple. Let's see. And then Props Off says, hello, everyone. Well, hello, Props Off. Good to see you. Well, guys, that looks like that's the end of it. That covers all the material. I don't see any other questions. Again, I want to say thanks not only to FlySky for sponsoring this video and sending this out. I'm encouraged with what I see here. I also want to say thanks to Richard for the work that I know that man is doing to get this integrated. And of course, to the rest of the EdgeTX team who are also involved in, you know, helping get things sorted out, getting telemetry sensors working and all of that stuff. So gratitude as always to all of our open source friends, including Captain Brian, the Express LRS team. I really, you know, for one, I just love you guys. Appreciate everything you do. And I hope you guys enjoyed the content. If you did, do me a favor, leave a comment after it's over. Give me a thumbs up. All that stuff helps the YouTube algorithm position my videos out there and help me grow the channel. So if you like this kind of stuff, it helps me back if you leave a thumbs up and leave a comment when the video's over, and then share it. You know, go into Facebook and tell people about it. You know, let them see what's going on. I appreciate that help back from you guys if you don't mind. With that said, that's all I've got for today. I hope you liked the material. Get out there and fly something.